Ever feel like algebra is just one long, complicated problem after another? Well, today, we're going to crack open a huge shortcut called the Quotient Rule for Exponents. Trust me, it's a total game changer for simplifying division, and in just the next few minutes, you'll see exactly how to use it.
So, take a look at this. At first glance, it looks like a real monster, doesn't it? You've got big numbers, different letters, exponents all over the place. It seems like it's designed to be a headache. But what if I told you there's a simple, super clean shortcut that makes solving this almost easy? Let's find out what it is.
So, what is this magic shortcut? Let's kick things off with the official rule, the one you'd find in a textbook. And then we'll break it down into plain English.
And here it is. This is the heart of the shortcut. The quotient rule tells us something really cool. When you're dividing two things that have the same base, like the x here, all you have to do is keep that base and subtract the exponents. Seriously, that's it. Let's just boil that down one more time. If you see the same base on the top and bottom of a fraction, and you're dividing, your brain should immediately go, oh, subtract the exponents. That is the number one thing to remember.
Now you could just memorize that rule, and you'd probably be fine. But the real power, the thing that makes it stick, is understanding why it works. When you get the why, you'll never, ever forget the how. So let's pull back the curtain and see what's really going on.
And it's a totally fair question, right? Why subtraction of all things? It might seem a little random at first, but there's a super simple visual reason that's going to make it all click. To really get the why, we're going to use a really simple example. Let's take x to the 5th power divided by x to the 3rd power.
So first, let's just remember what x to the 5th power even means. It's not complicated. It's just x multiplied by itself 5 times. We can write it all out the long way.
And you guessed it, we're going to do the exact same thing for the bottom. X to the 3rd power is just x times x times x.
Okay, so if we rewrite our original problem using these long expanded forms, this is what we're actually looking at. 5x's on top and 3x's on the bottom. And now for the fun part. Since anything divided by itself is just 1, we can start canceling out pairs of x's. We'll take 1 from the top and 1 from the bottom. Poof, they're gone. Let's do another pair, and a third pair. So after all that canceling, what do we have left over? Well, we've just got 2 x's being multiplied together up top, which of course is just x squared. And here is the aha moment. The long way gave us x squared, but look at our shortcut. 5 minus 3 is 2. See? Subtracting the exponents isn't some random rule. It's just a super fast way to do all of that writing out and canceling. That's why it works. All right, so now you know the rule, and you know why it's a rule in the first place. Let's put this new knowledge to the test with a couple of examples. This one might look a little tricky because it has 2 different letters, but don't worry, the process is exactly the same. We just handle each variable one at a time. So for the p's, we just subtract. 9 minus 5 is 4. Then for the q's, 16 minus 4 is 12. So our final answer is p to the 4th, q to the 12th. See? Pretty straightforward. Okay, so what happens when we have regular numbers, what we call coefficients, out in front? Let's break this next one down step by step. We just add one little step right at the beginning. First, you deal with the big numbers, the coefficients, and you just divide them like normal. 6 divided by 2 is 3. Easy enough. Next, you use our new quotient rule for the variables. For x, we subtract the exponents. 4 minus 3 is 1. That gives us 3x to the 1st power, which we can just write as 3x.
That last example actually brings up a really common trap that a lot of people fall into. So let's take a quick look at it so you can make sure you steer clear.
This is, without a doubt, the number one mistake. Because your brain is in subtraction mode for the exponents, it's so easy to accidentally subtract the big numbers too. But you gotta remember, coefficients are just regular old numbers. You have to follow the regular rules of division. You must divide the coefficients. 6 divided by 2 is 3, not 4. So, here's a little phrase to lock into your brain. Just repeat it to yourself. Divide the big numbers, subtract the small exponents. If you can remember that little rhyme, you will never mix them up. Okay, we've gone over the rule, we know why it works, and we know the big mistake to avoid. Now, it's your turn to put it all together. Hey, remember this guy from the very beginning? Well, now you have all the tools you need to solve it. So go ahead, grab a piece of paper, hit pause right here, and give it a shot.
I'll be right here when you get back.
All right, welcome back. Let's walk through it together. First step, the numbers. 36 over 54, that fraction simplifies down to 2 over 3. Next, the m's. 9 minus 3 gives us m to the 6th power. And finally, the n's. 5 minus 2 is n to the 3rd. You put it all together, and you get 2/3 m to the 6th, n to the 3rd. So, how'd you do?
You did some fantastic work today. You have officially leveled up your algebra skills. But learning this new rule opens up a really interesting question, doesn't it? What happens if the bigger exponent is on the bottom? What does it even mean when you subtract and get a negative exponent? Well, that's exactly what we're going to dive into next time. See you then.